All right, hello. Welcome to Brunei Math Club. In this video, we study some basics of matrices. A matrix is a two-dimensional array of numbers, such as this. And each of these elements, and they are called elements, are numbers, like real numbers or complex numbers or whatever numbers. And in this case, there are m rows and n columns. So this is called an m by n matrix. And usually we name a matrix by some letter, for example, capital letter A. And in this video, we study some basics like equality between two matrices and addition and subtraction of matrices. Okay, let's start. First, let's see some concrete examples. For example, let's say A is a matrix made of -2, 3, 4, -1. So this is an example of 2 by 2 matrix. And let's say B, matrix B is 1, 3, 0, 5, 2, 4. In this case, there are 2 rows and 3 columns, so this is a 2 by 3 matrix. And another example, let's say C is made of 1, -3, 0, 5, 2, 4, -1, -2, 0. This is an example of 3 by 3 matrix. So there can be any number of rows and any number of columns. And of course, we can also consider 1 by 1 matrix, such as this one. 1 by 1 matrix, but usually we regard this as just a number. Okay, so 1 by 1 matrix is same as numbers. Okay, and there are also special type of matrices such as this one, 1, 2, 3. Let's say this is 3 by 1 matrix. This is made of just one column. Such a matrix is called a column vector. And similarly, matrices such as 1, 2, 3, 4. In this case, this is 1 by 4 matrix. This is also called a vector, but in this case, it's a row vector because it's made of one row. For vectors, we usually name it by a lowercase letter, such as this, but with a boldface. Okay. In handwriting, boldface is hard to write, so in this lecture, I use wavy underline like this one. So same for row vectors. In the previous examples, let's pick this one, C. So each column is a column vector. So this matrix C consists of 3 column vectors or 3 row vectors. And for a matrix like this one, we identify the position of the matrix by the row number and the column number. So the element at the ith row and jth column is called the ij element of the matrix. And in this case, we write A, I, J. So this indicates the element at the ith row and jth column. Okay, so for example, in this case, this one, A22 is at the second row and the second column. So its 22 element is A22. And in this example, the first row and the second column intersects at this point. So let's say B's elements are written as Bij. In this case, B12 is equal to -3. So that is this element. Now, suppose we have two matrices, A and B. What do we mean by saying A is equal to B? So that means, first of all, their sizes must match. That means the number of rows in A must match the number of rows in B, and the number of columns in A should match the number of columns in B. That's the first condition. And the second condition is that the corresponding elements should be equal. So A11 should be equal to B11, and A22 should be equal to B22, and so on. And that's for the first row, and same for the second row and third row, and so on. All the rows and all the columns. So we say Aij is equal to Bij, where I ranges from 1, 2 up to the number of rows, let's say m, and j is equal to 1, 2 up to n number of columns. So if given two matrices, their sizes match and their elements match, then they are equal. If we have a matrix A with its elements A, I, J, then we can explicitly point the elements like this one. But if we are just given a matrix A without specifying its elements, then we can point to ij element like this one, like this expression in this lecture. There are many ways to write it, but in this lecture I write like this. Okay, so if its elements are given like this, then this A parenthesis ij is equal to aij. So it's just an ij element of this matrix A. So if two matrices are equal, then each of their corresponding pair of elements are equal. So in this case, we don't have to write down the matrix like this, but we can just use these symbols to express the equality, element-wise equality, right? Let's see a few examples. Suppose we have matrix 1, 2, 3, 4, and matrix 3, 1, 2, 4, let's say. These two matrices are not equal because their corresponding elements are not equal, although their sizes are equal. Okay? And consider another matrix, 3, 1, 2, 5, 6, 8. And this matrix cannot be equal because their sizes are different. Okay? And of course, if we have another matrix, 1, 2, 3, 4, let's say this is A and this is B, and A is equal to B because their sizes are same and their corresponding elements are the same. Okay. Now let's define the addition between two matrices. Suppose we have two matrices A made of Aij and B made of Bij. Then the addition between them is this. We are assuming they have the same size, okay? So they are both some m by n matrices. So this is defined element-wise. So the ij element of this new matrix, A plus B, so this is a new matrix, is Aij plus Bij, which means the 1, 1 element of this new matrix A plus B is A11 plus B11, and the 1, 2 element of this new matrix A plus B is A12 plus B12, and so on. And similarly, we can define the subtraction between two matrices. A minus B is defined element-wise. Aij minus Bij, which means the 1, 1 element of this new matrix, A minus B, is A11 minus B11, and the 1, 2 element is A12 minus B12, and so on. And same for all the all the other rows. In alternative notations, we can define the addition like this. The ij element of a plus b is equal to the sum of the ij element of a and the ij element of b. And similarly, the ij element of a minus b is equal to the difference between the ij element of a and the ij element of b. We are saying the same thing here as this. And next, we define something called the scalar multiplication. Let's say k is a constant. It can be a real number or a complex number or whatever numbers. Then the scalar multiplication between this constant k and the matrix is defined as the element-wise multiplication between each element and this constant. Constant is also called a scalar, k, I, j. So this means the ij element of this new matrix Ka is k times a11, k times a12, and so on. So each element is multiplied or scaled by the constant k. That's why we call it a scalar multiplication. And if you prefer the alternative notation, the scalar multiplication is defined by this. So the ij element of this new matrix Ka is equal to the product between the scalar k and the ij element of A. We are saying the same thing as here. In a special case where k happens to be equal to -1, then -1 times A is abbreviated as just -A. So although we define the subtraction between two matrices as this one, this can be reduced to just addition and scalar multiplication, right? So A minus B is equal to A plus -B. So which is A plus -1 times B. So subtraction of matrices is just addition and scalar multiplication. Okay, let's do some simple exercises. Suppose we have two matrices. Let's say A is made of 5, -3, -1, 4, and B is made of 4, -2, 0, 2. So they are both 2 by 2 matrices. So we can add them or make difference between them. And let's also calculate the scalar multiplication of one of these matrices. Okay, so A plus B is just element-wise addition. So 5 plus 4, that's 9. -3 plus -2, that's -5. And this is 1 and 4 and 2, that's 6. Easy. And A minus B is 5 minus 4 is 1, -3 minus -2 is -1, and this is -1, 4 minus 2 is 2, and easy. And 2a, for example, is just 2 times each element. 5 times 2 is 10, and 2 times -3 is 6, 2 times -1 is -2, 2 times 4 is 8. That's it. Okay, here's another exercise. Suppose these two matrices are equal. Then what are the possible values of these variables, A, B, C, D? So since these two matrices are equal, corresponding elements should be equal. So A must be equal to -2. That's easy. And negative 3 should be equal to negative 3c, negative 3c. So this means c is equal to negative 1. And 0 should be equal to d minus 1. So therefore, d should be equal to 1. And what about b? So negative 3 minus b should be equal to 2b. From here, we have, let's say, b should be equal to 1. So in conclusion, a is negative 2, b is 1, c is negative 1, and d is 1. Regarding addition and subtraction, there is a special class of matrices called zero matrices. For example, 0, 0, 0, 0 is an example of zero matrix. It's a 2 by 2 zero matrix. And zero matrices are made of just zeros, okay? So 0, 0, 0, 0, 0, 0. So this is a 2 by 3 zero matrix. 0, 0, 0, 0, 0, 0, 0, 0, 0. This is a 3 by 3 zero matrix. We usually denote the zero matrix by the capital letter O. And to indicate the size, we might use 2 like this. So this is a 2 by 2 zero matrix. This is 2 by 3 zero matrix. This is 3 by 3 zero matrix. If there's no fear of confusion, then we just omit these numbers and just write O. Okay. So suppose A and O they have the same size, then we can add them. And A plus O, you should try to prove this, is equal to O plus A is equal to A. Because all the elements of this zero matrix are 0. So if we add 0 to any number, the number doesn't change. So A plus O plus A is equal to A. So this zero matrix behaves just like the 0 in numbers. Let's see a little bit more concrete example. Suppose we have a matrix made of A, B, C, D. And if we add the zero matrix, 2 by 2 zero matrix, that is A plus 0, B plus 0, C plus 0, D plus 0, which is A, B, C, D. So this is the same as this one. So adding the zero matrix doesn't change the matrix. And by the way, the addition of matrix is commutative, meaning A plus B is equal to B plus A. And you should try that because addition is just defined element-wise. So for each element, A plus B is equal to B plus A. So this holds. So addition of matrices is commutative. Just to be sure, subtraction is not commutative, just like numbers, right? So for numbers, 1 minus 2 is equal to negative 1, but 2 minus 1 is equal to 1. So they are not equal, right? And same for matrices, A minus B. If A and B are matrices of the same size, A minus B is not equal to B minus A. This doesn't hold, of course. Okay, I hope that was easy enough for you. And in the next lecture, in the next video, we will study matrix product. That is the product between two matrices. Okay, see you later. Bye. Thanks for watching. If you like this video, please hit the like button and subscribe to this channel. See you next time. Bye.